Okay, in the first video, I explained the idea of parallax and how, when we're in one position around the sun, we'll see a star in one place in the sky. And then when we move to a different position around the sun, we'll see that same star in a different position in the sky. And it'll move. If it's closer to us, it'll move more. If it's further away from us, it'll move less. And that's the whole idea of parallax. Objects that are far away don't move as much as objects that are close by. All right. Now, we can use that to figure out and estimate the distance of a faraway star. Not too far away. All right. If it's too far away, then this doesn't really work. And another warning: this is real basic explanation of parallax. It's not for AP physics. It's not for college astronomy. This is for middle school science. So having said that, just roll with me. Believe what I say. All right. So what scientists will do, they'll find a star, and they'll pick a time of the year when, if we are looking at it, we see the star from that angle, and then 6 months later, we'll see the star kind of like this, and it makes like this perfect triangle. And thus we can also split up that triangle. I'm going to take that triangle and divide it, bisect it, like that. And so this angle and that angle are equal because we've bisected it. And so what we end up with is a right triangle, something like that. Okay, here's our right triangle, 90 degrees. And if you know anything about right triangles, you can do a lot of stuff with that. And so remember, we're trying to figure out this distance, the distance of this line. We'll call that x. We already know the distance of this line. We'll call this y. The distance of that line, y, equals the distance to the sun, which is also called an AU, an astronomical unit, and that is 150 million kilometers. Okay, it's science, so we're going to talk in kilometers. And so what we end up with is this line. We know this line, and we can calculate this angle, and we'll call that theta. And what we end up with is a tangent, a tangent formula. So we get, and if you remember basic geometry, tangent equals the opposite over the adjacent, right? Remember SOHCAHTOA, TOA. This is the TOA part. And our formula will end up being the tangent of theta equals the opposite, which is x, over our y, which is 150 million kilometers. All right, so let's say, for instance, that this theta, tangent of theta, is 70. Okay, because it's a pretty big angle, and it's going to be a pretty big angle. It's going to be close to 90 degrees because this star should actually be way, way off the screen. All right, so let's just call it 70. So tangent of 70 degrees equals x over 150 million kilometers. Okay, and we'll get out our handy dandy scientific online calculator. I'm looking at it, and whenever you're doing something like this, make sure you're not in radians, you're in degrees. Okay, so we have the tangent of 70, and it's going to equal 2.747. All right, so we get 2.747 equals x over 150 million kilometers. And so what do? We multiply both sides by 150 million. All right, 150 million. Okay, let's get the calculator back out. So we're going to multiply this number times 150, and then 6 zeros, 1, 2, 3, 4, 5, 6, and we end up with this number here, 412 million. Okay, 412 million kilometers. So we get 412, and we'll just round that off to 412 million. I'm sorry, kilometers equals x. So this would be the distance of this line here. So this star is approximately 412 million kilometers away using parallax, using the idea of parallax, and a little bit of basic geometry. So I thought it was pretty cool. It kind of ties in why, a way math and science are hand in hand with one another, brother and sister, you might call it. And hope you understood it. Hope you thought it was cool. And I'll see you later.